Recently, big headlines were made and have circulated the internet about the striking results of a new Alzheimer's drug trial. The drug, called aducanumab, sent major shockwaves through the internet, medical community, for its ability to reduce the amount of plaque in the brain. Plaque is one of the characteristic features of Alzheimer's disease. It aggregates to pathological levels. But we have Dr. Richard Isaacson here, who's a neurologist. He focuses on Alzheimer's prevention. He treats Alzheimer's patients, as well as those who are asymptomatic. And so I just wanted to share with you guys his thoughts on these new drug results.
Yeah, so the great news is that we are having great results. Now, it doesn't mean that we're going to have a blockbuster drug on the market tomorrow, but it means that over the last several years, decades in fact, we actually have made progress. And people say, oh, all these drugs don't do anything and we're making no progress and there's no hope. Absolutely not, okay? If there's one thing that this study shows is that there's absolutely hope. I'm not going to say that I'm certain, 100% certain that this is going to be that blockbuster drug, but I'm cautiously optimistic and more towards optimistic. Whether it's this drug or another one of its sister drugs, we've been using targeted therapies that get the gunk in the brain. You talked about the plaques. Plaques, it's this funny protein. It's called amyloid protein. You've probably heard of it. It gets gunked up in the brain. And over the last decade, literally, I enrolled my first patient in a trial with a similar drug in 2006. These drugs have been around, but the problem is we were either using them at not high enough doses, we were using them too late in the course of the disease when someone already had dementia and wasn't able to care for themselves, or we were using them in everybody, but it may only work preferentially in certain people. Well, what we're doing now, 10 years later, is we're setting up the trials to be able to determine, do these drugs work in person X versus Y versus Z? Does it work in someone with normal memory or someone with just a little bit of memory problems or someone with mild dementia or further? And this is how we're going to try to prove whether these drugs work or not. When it comes to this new study, I agree it's absolutely exciting. Why? Well, it was published in the Journal of Nature, published on September 1st, 2016. And this study showed that not only can this drug reduce the bad protein, the amyloid protein in the brain, but it was also associated with improvements in cognitive function. Now, the caveat here, the problem is that this was a very small study. It was 165 patients. Okay, well, that sounds decent, but there were 4 groups. There was a 1 milligram dose, a 3 milligram dose, a 6 milligram dose, a 10 milligram dose, and a placebo. And the key here is when you have all those patients, but you're in small doses, small groups, you don't really know for sure if things are working. Also, this was not a study that was designed to truly and adequately and scientifically assess whether the drug works or not. This was a safety study. We were just trying to figure out, does the drug work in terms of not causing side effects, not does the drug work in terms of improving memory and doing other things. So the follow-up studies that are ongoing now, the ENGAGE trial and the EMERGE trial, they're ongoing now. They're being done at the same time, and that's great because instead of in the past we would do research studies and we'd have to wait 5 years to do one study, and if that was positive we would do another 5-year study. So it would take 10 years for that drug to come out. Well, guess what? The company has said, you know what, this is an important area. Our initial results look okay. Let's do 2 studies at once, and that basically cuts in half the amount of time it will take for this drug to get to market if the drug is successful. And again, I'm cautiously optimistic, more towards optimistic. If it's not this drug, it's going to be a similar sister drug. Whether this drug comes out in 3, 5, or 7 years, I don't know. Whether the sister drug comes out in 3, 4, or 5 years, maybe a little bit earlier, I don't know. Which drug will be a home run? Which drug will be a single or a double? We don't know. But the point is that we can talk about these things. We can finally have excitement, and we can know that these therapies are right around the corner, so to speak.
And the other thing, another reason why people that are experts in Alzheimer's disease, such as yourself and your colleagues in neurology, have reserved a bit of caution around these results is that sometimes in the past, lowering amyloid plaque in the brain, which is what this drug has shown to be very effective at, hasn't always correlated with the most meaningful result that people hope for, which is an improvement in cognitive function.
Totally. And the first drug that really kind of gave birth to all these sister drugs did exactly that. It worked so well, in fact, to getting rid of the amyloid, that it actually caused a bad reaction in the brain, and people died because of it. It worked too well. Aside from that, it worked well to get rid of the protein, but it didn't improve cognitive function.
Wow.
The follow-up studies that were done with different drugs, sister drugs to this, also improved amyloid, like you're saying, but the cognitive function didn't improve. Now, is that because the horse was already out of the barn, meaning the person was too far along in the course of Alzheimer's? Alzheimer's starts in the brain 20 to 30 years before the first symptoms. So when someone is having symptoms and then someone progresses to dementia, the person's had the disease for 35 years.
Wow.
It's a real hard mission to put a drug in to get rid of the amyloid when the person's had it for 35 years. If we can give these drugs pre-symptomatically before the symptoms start, but when we know that there's amyloid in the brain, we can do scans and PET scans and fancy neuroimaging, brain imaging tests to detect this. That's when these drugs have the most chance for success. And that's why the past studies failed, but maybe we're going to make some progress here. The other point you made, you said scientists are skeptical, and I'm cautiously optimistic. Let's focus on the cautious for a second. There's something called the amyloid hypothesis. The amyloid hypothesis, what that means in scientific jargon, is that amyloid is a bad protein. And what I was taught in medical school was that amyloid is the thing that causes Alzheimer's disease. And I'm in the minority, less than a few percent of people out there, that do not believe that amyloid causes Alzheimer's disease. Now, I believe that amyloid's a part of it. I believe amyloid is the garbage that accumulates towards the end of a course of a disease. Okay, the end meaning maybe 20 or 30 years, and then you start seeing the tip of the iceberg, right? You see the dementia that persists. But amyloid is the garbage that accumulates, and if you don't take the garbage out, you're going to get sick. If we can take the garbage out, the person may do better. But the key here with true both Alzheimer's prevention and treatment is that if we can figure out how to reduce amyloid accumulation, if we can intervene years before, if we can figure out why a person is going to go down the road of Alzheimer's, there's many roads, I believe, there's many roads that a person can take to Alzheimer's disease. Amyloid is the downstream effect, the end of the road, some would say. But some may be on the metabolic pathway, some may be on the lipid pathway, some may be on the nutritional pathway. And what we need to do, and where the future of Alzheimer's is going, is to figure out where each person is, which road they're on, and get them to take a detour, okay? In the future, if I had a crystal ball, we're going to be using multiple things to treat and prevent Alzheimer's. So currently we talk about exercise, we talk about nutrition, we talk about certain supplements, we talk about managing cholesterol and diabetes and reducing blood sugar and all this different stuff. Well, one day we're going to have a blockbuster drug, but we're still going to do all the other things. Okay, that blockbuster drug may only work on amyloid. We're still going to need to do everything else. In the future, we may have a drug that works on a tau protein. You heard about amyloid protein, there's tau. I hope we're going to have a tau busting drug. In the future, we're probably going to have something that will affect brain metabolism, glucose hypometabolism, reduced ability of the brain to use sugar as a primary source of fuel. That's a whole lot of words. What it basically means is I think that there will be therapies out there that can help the brain metabolize better and more efficiently. And the goal here, the holy grail of Alzheimer's disease, both prevention and treatment, is to hit this disease from every angle. And amyloid may be one part of the path. The current drugs that are available now, well, they help a little bit. They help with symptoms a little bit. They're not miracle drugs, but we're still going to use these drugs. We have to use everything together, and that's where Alzheimer's is going to be in 5 to 10 years from now.
Boom. That was amazing. And if any of you guys have followed my work on social media, you know that I support his work. I'm a believer, based on my own analysis of the research, that this is definitely the future, and it's very exciting, very exciting. They say that 90% of what we know about Alzheimer's disease has been discovered only in the past 15 years, which is astonishing to consider the progress that we've made and will continue to make as years pass. So I'm super excited, and I appreciate your work, so thank you.
Absolutely. Thank you.